Factor trees. So we use these to write a number as the product of powers of prime. So you need to be able to identify factors of a number and recognise which ones of those are prime factors. When we're writing our numbers as the product of powers of prime, we use our index notation. So index notation is used to simplify an expression. So for an example, something in expanded form could be 5 times 5 times 5 times 5. So to simplify this, we use our index notation 5 to the power of 4. So we have our base number of 5 and then our power of 4, and all this means is the exact same thing, that it's 5 multiplied by itself 4 times. Now, to construct a factor tree, what we need to do is you need to identify, first of all, what the number is you're constructing a factor tree for. You then need to identify factors of the value. You then need to select a pair of factors, which can be any of them, but do not use the one that has a factor of 1. We then begin the tree, we split it into factors, and we continue doing that along each branch until the end of each branch has a prime value. So our worked examples. If we construct a factor tree for 100, so we start with 100. Now, up here next to 100, I'm just going to write our factors of 100. So we've got 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Now, straight away, I know I can't use the 1 and 100, because if I use 1, I'm basically just starting from the beginning again with the 100, so there's no point of using the 1 and 100. I'm going to choose here where one of the values is already a prime number. So I'm going to either choose 2 and 50 or 5 and 20. So for this case here, what I'm going to do is I'm going to choose 5 and 20. So I split 100 into 5 and 20, okay, because 5 times 20 is 100. I then have a look at those two and I say, okay, 5 is prime, so I need to circle that to say that that's the end of that branch. I then go to 20 and I say, okay, well, what are factors of 20? So here I'm going to split 20 and I'm going to use 2 and 10. So 2 is prime, so I circle that, 10 is not, so we need to split it further. Factors of 10, I've got 2 and 5. 2 is prime, and so is 5. So there we go, our factor tree is now complete because we've gotten all the way down to all prime values. Okay, for example 2, we want to construct a factor tree for 75. So again, we need to work out, okay, well, factors of 75. So the first branch that I'm going to do is 3 and 25. I chose that because I know that 3 is prime. So then I can circle that to show that that's a prime value. I then look at 25 and say, okay, how can I split that? Well, 5 times 5 is 25, and 5 is a prime number as well. So then my factor tree is completed for 75. Example 3 then wants us to write our value as a product of powers of prime. So I start with my factor tree. So I start with 125. And I split that, so I've got 5 times 25 is 125. I circle 5 because that is a prime value. I split 25. 5 times 5 is 25. They are both prime. Now, because I'm writing my value as a product of powers of prime, what I then need to do is I've got 125 equals, and I write all of my prime values with a multiplication in between. So I've got 5 times 5 times 5. Now I then simplify that by writing it in index form. So base 5 to the power of 3. Okay, and our fourth example here, I want to write 99 as the product of powers of prime values. So what I'm going to do is I'm going to split our 99. So 11 times 9 is 99. 11 is prime. I then need to split 9. So 3 times 3 is 9. 3 is prime. So then what that means is 99 equals 11 times 3 times 3. We simplify that, so we've got 11 times 3 squared. And then generally by convention what we do is, because they're all being multiplied, we can write them in any order, and we generally write our smaller numerals first. So it'll be 3 squared times 11. And then we've written our when 99 is a product of powers of prime.